Hey guys, today we're gonna be talking about Clojure programming, a dive into functional programming and concurrency. For today's presentation, we'll focus on just a few topics in Clojure programming. First and foremost, we'll start with the introduction, functional programming in Clojure, syntax and semantics of Clojure, concurrency and parallelism with Clojure, web development with Clojure, and tooling and ecosystem. So these topics are what we're gonna focus on during this presentation. Clojure is a dynamic and functional dialect of Lisp programming languages. It was created by Rick Hickey in mid-2000s, um, primarily for Java platform. It also emphasizes on functional programming, avoiding mutable states, and treat functions as first-class objects. It aims for most parts of the programs to be functional, leading to more robust applications. This presentation will dive into Clojure's unique features, its philosophies, and its practical applications in the ever-evolving landscape of software development. Um, Going into functional programming, we have immutability, functions as first-class citizens, emphasis on recursion, high-order functions, and lazy evaluation. For immutability, in Clojure, data structures are immutable by default. This means that once a data structure is created, it cannot be altered in any place. Instead, any modification creates a new data structure. This approach simplifies reasoning about code and enhances trust and safety in concurrent programming. Function as first-class citizens. Functions in Clojure are treated as first-class citizens. This means you can use your function just like any other data type, like passing them as arguments or returning them from other functions and assigning them to variables. Emphasis on recursion. Clojure encourages the use of recursion for looping or iterating over data. Rather than traditional iterative constructs like for or while loops, this aligns with the functional programming. This aligns with the functional programming principle of avoiding side effects. For high-order functions, Clojure supports high-order functions, which are functions that take other functions as arguments or return them as results. This feature is central to functional programming and enables powerful abstractions and composability in code. For lazy evaluation, Clojure supports lazy evaluation in sequence processing, meaning that computational elements of a sequence are only evaluated when needed, not upfront. This allows for effective handling of large or even infinite data structures. Okay, so here we have a code snippet explaining exactly what I just said in the last slide. For line 1 to 3, it's a function named square. It takes one parameter x and returns the result by multiplying x by itself, effectively squaring. So basically, if you have 2 in place of x, it's going to be 4. If you have 6 in place of x, it's going to be 36. For line 5 and 6, this defines a vector named numbers containing the numbers 1, 2, 3, 4, 5. For line 8 and 9, this map function is applied to square function and the numbers vector. It applies the square function to each element in the numbers vectors, resulting in a lazy sequence of squared numbers. And here on the right side, we see this is the printed result. We have 1, 4, 9, 16, and 25, which are all squares of the numbers, the numbers in the vector list. Diving into syntax and semantics, we have S expressions, code as data, keyword and symbols, and functions and definitions. Clojure syntax is primarily built on X expressions, which are parenthesized expressions. They consist of an operator followed by its operands and enclosed in parentheses. Examples are like +1, just like we have in Java and Python, where we have a plus plus, meaning that's an increment of an a. But in Clojure, it's +1, 2, 3, which represents the addition of the numbers 1, 2, and 3. Code as data. In Clojure, code and data share the same data structure. The concept is known as code as data. Programs can manipulate and generate code as if it were data. Example, we have define square x, like the last code snippet I showed you guys. It defines a function named square using the same same list structure that represent data. We have keywords. Keywords denoted by a colon are used to represent constants. Symbols represent variables. So, example, if you have like a semicolon keyword and my symbol, so like semicolon keyword, that's a constant actually. I'm sorry. So for function and definitions, function and definitions are use the def and keyword, and variables are defined using def. So like the last code snippet define square x. So the function def n defines a list. So this oh yeah, let me start by like explaining what each function does in this code snippet. The checking sign function takes a parameter x. The if statement checks if whether the x is greater or equal to 0. If the condition is true, it returns a string positive. Otherwise, it returns negative. The function is then tested with 2 examples, and the results are printed using a print link. So we have the output on the right side, which says that. So what you notice, like the conditional statement is a little different from other languages we've been through, like Python and Java and C++. So diving into concurrency and parallelism and Clojure, immutability and state management, shared data structures, reduction with reduce and reduce KV. Clojure actually promotes immutability, like I said last 4 slides. As a fundamental principle, most data structures in Clojure are immutable by default. This makes it easier to reason about and manage state in concurrent programs. Clojure provides persistent data structure which can be safely shared between threads. These data structures are designed to be thread safe and efficient for concurrent access. So for reducing and reduction will reduce and KV. Clojure provides reduce and reduce KV functions. So the word reduce and reduce KV are functions that can be used with a fold library to perform parallel reductions. In summary, basically, it's like Clojure offers a wide range of concurrency and parallelism tools to simplify the development of concurrent and parallel programs while maintaining safety and simplicity. Developers can choose the appropriate mechanism based on the specific requirements of the application, whether it's managing shared state, coordinating updates, or parallel processing of data. This feature makes Clojure a robust choice for building concurrent and parallel software. So now diving into web development with Clojure. Web development with Clojure offers a productive and flexible environment for building web applications. Clojure provides a variety of libraries and frameworks tailored to web development, making it well suited for both server-side and client-side development. So Ring is a core library for handling HTTP requests and responses in Clojure web applications. It also provides a simple and composable interface for building web servers and middleware. So this is a little code snippet on the right side showing how Ring handles the HTTP request and responses. Libraries for database access. Clojure provides libraries like Clojure.java.jdbc or Hog SQL. You can easily connect to a relational database and perform SQL queries using Clojure.java.jdbc. It's a code snippet and for an example of how you can use the SQL queries to perform SQL queries from database. Libraries for API development. Libraries like Liberator and BD are available for building RESTful APIs and handling routing. Example using Liberator. We have last but not least deployment. Clojure web applications can be deployed to various platforms, including traditional web servers, platforms like AWS, Heroku, and container orchestration systems like Docker and Kubernetes. Basically, so Clojure provides a rich ecosystem for web development with libraries and frameworks that streamline various aspects of building web applications. Its functional programming features seamlessly Java interoperability and expressive syntax, making it a compelling choice for both server-side and client-side web development. Now diving into tooling and ecosystem. I haven't happened. Learningen is de facto built for Clojure project. It simplifies project setup, dependencies, management, and build tags. The developer can create, configure, and manage projects effortlessly. For Clojure scripts, it's a compiler that allows Clojure code to be transpiled into JavaScript. It's opened up the world of client-side web development for Clojure developers. For IDE support, Clojure has a strong support in IDEs like IntelliJ, IDEA, and Visual Studio Code. Put in mind you have to install the Carver extension. It took me a while to get that, but you have to install the Carver extension unless your code is not gonna run in Visual Studio Code. For what's it called? Rep, read, eval, print loop. The Clojure rep is a powerful tool for interactive development. It allows developers to experiment with code, evaluate expression, and receive immediate feedback. Libraries and framework. Clojure has a rich ecosystem of libraries and frameworks for various purposes, including web development and data processing and functional programming. Summary, Clojure's tooling and ecosystem offers a comprehensive set of resources for building and testing and deploying Clojure projects. Whether you're a web developer, data scientist, or functional programming enthusiast, Clojure provides the tools and libraries to support your development needs. The active community and strong documentation further enhances the experience of working with Clojure. I think this should be the last one. So now diving into challenges and considerations. While Clojure offers many benefits, it also presents certain challenges and considerations that developers should be aware of, or you guys should be aware of when choosing it as a programming language. Learning curve. Clojure's lib syntax and functional programming paradigm can be unfamiliar to developers coming from more mainstream languages like Python, Java, C++, C. Learning to think functionally and understand the lib's macros may require a lot of time and effort. Let's talk about the limited job market. Compared to popular languages like Java and Python and JavaScript, the job market for Clojure is relatively small. Finding job opportunities that specifically require Clojure expertise can be challenging in some regions, especially in 2023, because the hot cake right now is probably Java, and not just modern languages like Python, Java, C++, Dart, and so many more. Debugging and tooling. While Clojure's REPL and debugging tools are powerful, they might not be as polished or feature-rich as those in mainstream languages and IDEs. This can be a challenge for developers accustomed to advanced debugging tools. Maintenance and compatibility. As a language that values simplicity, Clojure may not receive frequent updates or feature additions. Developers using cutting-edge features or dependent on specific libraries should consider long-term maintenance and compatibility. Basically, conclusion: while Clojure offers unique advantages in terms of conciseness, simplicity, and functional programming, it also comes with challenges, which I just listed, related to learning and community size and interoperability. Developers considering Clojure should evaluate their project's requirements and assess whether Clojure's strength aligns with their goals. Additionally, familiarity with the language and its ecosystem can help mitigate some of the challenges mentioned. above, which I just mentioned. So I think this is all I have to say on Clojure programming. If you guys have any questions or contribution, please post it in the discussion. Yeah, thank you.